Okay, so good morning, everyone. So today, it's been a while. So we have completed the Linux fundamentals a while back. So today we are going through the networking basics. So before going to the other DevOps things, it's better you start from the scratch and know the things. Okay, and I am thinking maybe it's 2 3 sessions. It depends, like 2 or 3 4 sessions mostly the networking fundamentals, so it would make your work easy later going forward. Yeah, just a second. Yeah. So let me know if you can see my screen, guys.
Yes, Sasi. Can you
Yeah,
increase the font size a bit?
yeah, sure. Is that okay, or should I increase the
Yeah,
window?
that's fine. That's fine. Thank you.
Yeah. So before going to networking, let's see what is the basic networking here. Okay. Um, Yeah. So what do you mean by networking is like we are trying to, it's basically a communication between two or multiple endpoints. Okay. So you have a point you have a person A and you have a person B. So the two persons or 2 points they're trying to communicate. So that is called networking. So it could include two or more. So we'll see it over here. So here we are trying to Yeah. So here we are trying to connect 2 points. So that is point A and point B. Here, these 2 points can be a persons also. So how do you communicate? How 2 points or two persons communicate, right? So two persons need a name, right? Otherwise, if we are trying to communicate over a call, the two persons need something called a number or an identity, like a phone number you can assume. The problem with name is the problem with the name is name can be a duplicate entry. There could be multiple persons with the same name or something similar. So here comes with the identity. The phone number would be a unique one to each person. So similarly, in the terms of computer networking, we do have something called IP address. Yeah. And if I see here, the sample IP address would be something like 192.168.0.1, and this one would be 192.168.0.2. So what is this IP notation and how we came here? Yes, that one I'll tell you. So let's take a scenario of a corporate networking. Okay. So let's take you are a school, you're maintaining a school network or a hospital network. So what do you look for is how do you manage the multiple people identities or multiple IP addresses, right? So that will start over here. So what is your network capacity, right? So how many how many addresses you would be needing? So I can assume 1024 or 256 or 512. So based on this, so I'll come and assign the IP addresses. So you are deciding like, okay, I might have 20 servers. So that is the reason I'm thinking of 20 IP addresses. So that would come over here. And even this 20 IP addresses, we will be subdividing. So let's take a scenario as we are going ahead with something called 1024 IP addresses. Okay. So what we will do, we will remove the, for now, we will forget the IP address thing. So we will just put a numbers over here. So even the 1024, we will divide into subnetworks. Okay. So let's say the total, my network capacity is 1000. Okay. Yeah, just a second. Yeah. So coming back, so let's say my network capacity is 1000. Okay. So you can consider something like a school network kind of thing. Okay. So here you will divide it into blocks, right? So it would be subnetwork A, subnetwork B, yeah, subnet C. Okay. So the here the capacity is 1000 as we mentioned earlier. So what we do, we will divide this 1000 into equal or unequal numbers. So we can consider the subnet A, we can have something like 200 IP addresses. So here's the thing. Let's say I'm deciding the IP address as this format, like 192.168.0.1 or this thing, right? So what is this format? This is a universal standard we are trying to maintain. Okay. So how does it say is like it'll go like this. So So usually this range goes like this. Okay. So 192.168.0.1, right? So this IP addresses, as I told, there is a standard. So for that standard, what we have is we have five different types of IP addresses. Okay. So that one would be class A, which we use for large networks. Class B, we use for medium scale networks. Class D, we use for unicast, as in the video broadcasting and other fields. And that would look like this. Yeah. So it goes like from basically how the network address comes is, if I open a notepad, so 0.0.1. So the next one would be 0.0.2, right? And it will keep on going 0.0.0 So that's the end here. And the next set will start like this: 1.0.0.1.0. So similarly, all the IP addresses will go like this. This is called subnet masking. So this is the maximum range of the IPv4 addresses. Okay. So there is a limit over here. This one would be somewhere around this number. And this limit is getting over now, okay, because everyone is trying to capture one address due to that the over the public internet. So due to that, the IPv4 is coming to end. But it's been saying like from last 4 5 years and all. But people are trying to adopt IPv6, Internet Protocol version 6. This one has some difficulties because your Wi-Fi router should support the IPv6. Your computer should support the IPv6. What are the softwares you are using? They should also support the IPv6. So it's slowly progressing currently. But maybe in the next 5 years, people start will using the IPv6, and that would go like octal format. Here we told the max number would be 0 to 255. There the max number will go from 0 to 9. After that, A to F. So instead of the binary format, we'll be using the octal format. And coming back, yeah, so this is a little tricky topic, this representation of IP addresses, but it's better you just have a look at it once, what exactly it is. And you might not need to calculate every time. Okay. So if I take this one, yeah, yeah, I'll take this sample IP address. This is a representation. This is a CADR representation. This is like classless interdomain routing. Okay. So without mentioning the class, if I want to mention what is my IP range of my particular subnet or the particular network, so I will mention with this one. Okay. /24. So this /24, it mentions the octal representation of the number of bits. So that would be like total 32 minus 20. So this is 8 bit. And this whole numbers we need to recalculate the binary. Okay. So what I'll do, I'll just simply decimal to binary. 192, 168, 0, but one would be, I think, one would be one, just 10, I guess. Yeah, it's one. So this is the binary representation. So this one, we will try to use it to calculate the number of IP addresses. Okay. So if I go back here, this one says we need to shift the range. So just give me a minute. I think this 24 also we need to convert. So the 24 would be, yeah, this one I'll come back, guys. I still need to double check the calculation. This one I'll come back, but instead we can use this one. So yeah, instead of, we can go ahead with the manual one. I'll explain this one. So instead of manual one, like whenever when we are working, if we are not able to, like if we cannot calculate properly, so we can use this one, the CIDR calculator. So here we do mention like the total IP range is 256 per 24. Okay, and the starting IP would start from here. and the ending IP would be here. The first IP, the last IP. And here we will maintain one IP for broadcast and one IP for gateway. So the usable IP would be somewhere around this 192.168.0.1, 254, you can say, because the last one also we use for gateway. Coming to this one, just yeah, okay, guys. So like I'll come back on this one, the subnet calculation. The for me, I'm not getting the proper number how to calculate this, but I'll come back on this. But instead, we can use this one subnet calculator anytime if we want to check. And coming back, yeah, so we'll be discussing the OSA layer. And after this, we'll go back and check for the TCP IP addresses in the next session. We can check for the TCP IP ports. And we do check the firewall, how the firewall works. And we can check the load balancer and DNS. So these are the topics I'm thinking right now. But if you think of any other topics, do let me know. So yeah, there is a OSA architecture. Okay. Yeah. So this is the OSI architecture. So you have layer 1 to layer 7. Okay. So how does it affect my day-to-day flow? It does not affect, but you should know like which layer your traffic, like which layer you're currently working on, right? So let's say your all your TCP, IP, all the HTTP and HTTPS applications, right? So all those things they do work under this one, the application layer, where you'll have the session cookies or your authentication. All that things they do work in the application layer. So if you come to physical layer, you will have something called MAC addresses. The for every network you have a MAC address. One second. Yeah. And presentation layer shows like you can do the data encryption and compression. So session layer will tell you like your store your session basically. So once you log in to your application and log out, the whole thing is called a session. I'll show you what is session. And the transport layer, this is where your TCP UDP TCP UDP protocols will be coming in. And the network layer, all your IP addresses, like the IP routing from one place to another, those things will come in. And the physical layer, it's in very raw state, like all your network cables or the RJ45 jacks, right? So all the raw bits and all those kind of things will be dealing in the physical layer. And data link layer, we do specifically mention as the MAC address will include here and the error detection. So yeah, that's about it. And later point of time, this layer has been converted into this one. Internet protocol. So the TCP IP protocol. In the TCP IP protocol, all these seven layers, right? So they managed and they packed it into, yeah, all these three layers, they packed it into application layer. Everything belonged to the application layer. And the rest of the layers will stay as it is. So from time to time, when you are working in when you're working regularly, there are some things comes like, okay, some component will work in layer 4, like take example load balancer. Some component will work in layer 7, and there is DNS and there is other components. So you might need to know, okay, which component will work in the which layer. So I'll try to show you that in the upcoming session. As of now, I'll try to conclude it here because I just roughly scratched the surface. So in the next session, I'll try to cover bit advanced topics. Yeah. Any questions, guys? Yeah. Any questions, guys? Or we are okay to conclude here? Okay, I don't see any questions for now. So I'll try to conclude today's session here. Hopefully we'll meet again. Like I'm planning like Sunday, I'll take one more session on 10 a.m. tomorrow. So we'll meet again then. Yeah. Prasad is asking, can we get the page for reference? Yes, I'll provide the notes, maybe in the Discord or wherever, right? I'll provide the notes over there. Yeah, this is as I told, this is just a basics. So I think most of the people already know. Maybe in the next session, yeah, I'll try to cover all the regular things, whatever we are using. Yeah, and most maybe we'll go to the Wireshark as well. So where we do analyze the packets. Yeah, thank you.